This is a video on corrosion for the Year 9 science course for the topic Chemical World. In another video, I explored the concept of combustion, and I mentioned briefly that corrosion was a form of combustion. Why is that? Well, because it involves the reaction between an oxygen and a metal to give you a metal oxide. The most common form of corrosion is the rusting of iron. So if you've got iron nails around the house or in the shed, in the garage, you'll see this sort of brown coating, and that's the result of the corrosion of iron. So when iron reacts with oxygen in the air, you get iron oxide. You get this brownish layer on the outside of the nail. Okay, and when iron reacts with oxygen to produce iron oxide, that's called rusting. Rusting only applies to iron, it doesn't apply to any other metal. If you've got aluminium oxide, for example, that's not called rusting, that's called corrosion. Let's look at the chemical formula, the chemical equation for the rusting of iron, and see what's happening. So iron plus oxygen, so let's say we have iron metal, Fe, plus 3 plus O2, oxygen, to give Fe2O3, iron oxide. How did I get this? Well, because if you recall from valencies, so Fe and O, oxygen has a valency of -2. Now the iron would have a valency in this case of +3 because the 3's come down. When you stick these together, the 3's come down to oxygen and the 2's come down to the iron. Now iron is a transition metal, and transition metals have valencies which vary. It could be +1, +2, +3, or +4. In an exam they'll specify. But in this case it's +3. So let's balance this. It's not balanced, as we'll see. So iron, oxygen, iron, oxygen. So to see, it's not balanced because you can clearly see there's 2 irons on the right, 1 on the left. There's 3 oxygens on the right and 2 on the left. So to balance, if you recall, you make a list from left to right. So I've written Fe for iron and oxygen next. On the left and on the right, it's the same thing in the same order, because you can't create or destroy atoms. So iron, there's 1 on the left, oxygen, there's 2 on the left, iron, there's 2 on the right, and oxygen, there's 3 on the right. Let's turn this 1 into a 2 by multiplying by 2 to get 2, and the 2 goes here. But the oxygen is in trouble. We need to, so 2 and 3, common factor is 6. Let's multiply this by 2 to get 6, so the 2 goes out here. Now the iron becomes 4, because there's 2 times 2 here, so that's 4. How do we get 4 here? By multiplying by 2 to get 4. So the 4 goes out here. To get 2 into a 6, we times it by 3 to get 6, and we put a 3 here. And that's the balanced chemical equation for the rusting of iron. Let's do another example. We've also got the corrosion of copper on water pipes. So not sure if they're still used today in plumbing, but copper was used a lot back in the day for water pipes. So I've definitely got some in my backyard exposed on the surface, and I can see sort of greenish blue color. That's corrosion of copper. Copper plus oxygen gives copper oxide. Copper is Cu, let's write the chemical equation now, plus O2 for oxygen makes CuO. Why is it CuO? Because I've taken, so CuO, I've taken the oxygen to have -2 valency and the copper to have +2 valency. So copper is a transition metal just like iron. I've chosen +2 because when you stick them together, the valencies cancel out, +2, -2. This isn't balanced. Copper, oxygen, because there's 2 oxygen on the left, 1 on the right. The copper's balanced. How do we turn the 2 on the right, the 1 on the right, into a 2? We multiply it by 2 to get 2. Put a 2 out the front. Now the copper becomes 2. To turn this into a 2, we multiply by 2. To get 2 and put the 2 at the front. Now it's balanced. So there's some examples of corrosion. And corrosion is actually not a bad thing in some cases, particularly for materials made of like aluminium. Aluminium, when exposed to oxygen, will make aluminium oxide. It's not a bad thing in this case because aluminium oxide will form a protective layer on top. So let's say I'll draw it in black over the white. It's a protective oxide surface, and that will prevent more oxygen from entering the inside of the metal, the aluminium. So that's an advantage there of corrosion. I'm sure you're familiar with tarnish on silver. Tarnish is that sort of hazy, foggy look on cutlery. So chemical reactions. So tarnish involves chemical reactions between sulfur containing substances in the air. And silver. So the sulfur in the air reacting with silver forms tarnish. Okay, that's silver plus sulfur gives you silver sulfide. That's called tarnish. Okay, commonly found on cutlery made of silver. The equation is Ag for silver plus S for sulfur makes Ag2S. Why is it Ag2S? Because sulfur is in the same group as oxygen. It's got a charge of -2 valency. And the silver, I've taken it to be +1. Silver is a transition metal, +1 valency. If you stick them together, AgS, the 2 comes down. This isn't balanced. Let's balance it. AgS, 1 Ag on the left, 1 sulfur on the left, 2 Ag on the right, 1 sulfur on the right. Let's turn this into a 2 by multiplying by 2 for the silver. 2 goes out the front. Now it's balanced. So that's an example there. Another common example is verdigris. On copper, we'll use sort of blue-green. Verdigris on copper. If you live in New York, you're familiar with this because the Statue of Liberty is an example of this. Verdigris is a poisonous grey-greenish substance, okay, due to copper reacting with oxygen or acetic acid. Acetic acid is commonly found in vinegar. So if you're cooking foods in copper pots and you're using acid like acetic acid, vinegar, the copper pot will eventually turn a sort of blue, green-grey color. That's verdigris. So copper plus oxygen forms copper oxide. That's known as verdigris. The Statue of Liberty has this color. So it was originally sort of bronze color due to the copper it's made of. Over time, because the copper would react with oxygen in the air, it formed the color that it has today. There's one thing I forgot to emphasize as well. Going back to aluminium. Aluminium doesn't rust, it corrodes. Aluminium has a protective surface, and so it prevents the aluminium below it from breaking down. Whereas iron, when it rusts, it gets weaker because it's got no protective surface, unlike aluminium. So that's corrosion in a nutshell.